Alan L. Bean, Owen K. Garriott, and Jack R. Lousma were astronauts who were part of the Skylab 3 mission, also known as SL-3, which was the second manned mission to Skylab, the first space station operated by the United States. The mission was launched on July 28, 1973, and ended on September 25, 1973, lasting a total of 59 days. Alan L. Bean was born on March 15, 1932, in Wheeler, Texas. He was a member of NASA's third group of astronauts, known as the scientist astronauts, because they had advanced degrees in science. Bean had a bachelor's degree in aeronautical engineering and a master's degree in aeronautical engineering from the University of Texas at Austin. Prior to becoming an astronaut, Bean was a U.S. Navy test pilot. During the Skylab 3 mission, Bean served as the commander of the Skylab 3 crew. He also performed 3 spacewalks, which lasted a total of 7 hours and 45 minutes, and conducted numerous scientific experiments, including observations of the Sun, the Earth, and other celestial objects. Owen K. Garriott was born on November 22, 1930, in Enid, Oklahoma. He was a member of NASA's 6th group of astronauts. Prior to becoming an astronaut, Garriott was a professor of electrical engineering at Stanford University. He also served in the U.S. Navy and worked for the Radio Corporation of America, RCA. During the Skylab 3 mission, Garriott served as the science pilot of the Skylab 3 crew. He conducted numerous scientific experiments, including experiments on the properties of fluids in a weightless environment, and experiments on the behavior of materials in space. Jack R. Lousma was born on February 29, 1936, in Grand Rapids, Michigan. He was a member of NASA's 5th group of astronauts. Prior to becoming an astronaut, Lousma was a U.S. Marine Corps pilot. He also worked as an engineer for the Ford Motor Company. During the Skylab 3 mission, Lousma served as the pilot of the Skylab 3 crew. He was responsible for piloting the Skylab spacecraft, as well as performing various maintenance tasks on the Skylab space station. He also conducted scientific experiments, including experiments on the properties of fluids in a weightless environment and experiments on the behavior of materials in space. Overall, the Skylab 3 mission was considered a success, and the crew set a record at the time for the longest manned spaceflight. The Skylab program paved the way for future space station missions, such as the International Space Station. Skylab was the first space station operated by the United States, and it was launched into orbit by NASA in 1973. The space station consisted of a workshop module and an orbital solar observatory, as well as a multiple docking adapter that allowed crewed spacecraft to dock with the station. Skylab was designed to support scientific research to test systems and technologies for long-duration human spaceflight. The Skylab 3 mission was the second manned mission to Skylab, and it followed the Skylab 2 mission, which had been launched 2 months earlier. The Skylab 3 crew spent almost 2 months in space, conducting a wide range of scientific experiments and carrying out maintenance tasks on the Skylab space station. They also made numerous observations of the Sun, the Earth, and other celestial objects, using a variety of scientific instruments and cameras. One of the highlights of the Skylab 3 mission was the crew's spacewalks, which were the first ever conducted outside of the Skylab space station. During their 3 spacewalks, Bean and Lousma conducted a variety of tasks, such as installing new equipment on the outside of the space station, retrieving film canisters from solar observatory cameras, and conducting repairs to the station's exterior. These spacewalks were crucial for the success of the Skylab program, as they demonstrated that astronauts could work effectively outside of a space station and perform complex tasks in a microgravity environment. After the Skylab 3 mission ended, the Skylab space station remained in orbit for several years, but eventually re-entered the Earth's atmosphere in 1979. The Skylab program was seen as a major milestone in the history of human spaceflight, and it paved the way for future space station missions, such as the International Space Station, which has been continuously occupied since 2000. Conducted by the Skylab 3 crew, the mission also had several other notable achievements. For example, the crew performed the first medical experiment in space to study the effects of weightlessness on the human body. They also carried out experiments to study the growth and development of plants in a microgravity environment, which had important implications for future space agriculture and life support systems. The Skylab 3 mission also set several records at the time, including the longest manned spaceflight, 59 days, the longest spacewalk, 7 hours and 45 minutes, and the largest amount of solar flare data collected during a single mission. The mission demonstrated that humans could live and work in space for extended periods of time, which was a crucial step towards future long-duration missions, such as those to the International Space Station and eventually to Mars. Following the Skylab 3 mission, Alan L. Bean went on to retire from NASA and became an artist, creating paintings that depicted his experiences as an astronaut. Owen K. Garriott flew on one more spaceflight, the Space Shuttle mission STS-9, in 1983, and later became a professor of physics at the University of Alabama. Jack R. Lousma flew on one more spaceflight, the Space Shuttle mission STS-41B, in 1984, and later became a business executive. The Skylab program, despite being short-lived, made significant contributions to the development of human spaceflight and space science. It paved the way for the Space Shuttle program, the International Space Station, and future missions to explore the solar system and beyond. The legacy of discoveries and technological advancements that were made possible by this pioneering space station. In addition to the scientific and technological achievements of the Skylab 3 mission, there were also some challenges that the crew faced during their time in space. One of the most notable challenges was a malfunction in the Skylab space station's thermal control system, which resulted in temperatures inside the workshop module reaching up to 126 degrees Fahrenheit, 52 degrees Celsius. The crew had to use a variety of improvised methods, such as using duct tape and a parasol, to try to regulate the temperature inside the space station. The crew also experienced some health issues during the mission, such as eye and sinus congestion, which were attributed to the microgravity environment. They were able to successfully manage these issues with the help of ground-based medical teams. Despite these challenges, the Skylab 3 mission was considered a great success, both in terms of the scientific discoveries made and the capabilities demonstrated by the crew. The Skylab program as a whole provided valuable insights into the challenges of living and working in space, and helped pave the way for future human spaceflight missions. It's worth noting that the Skylab program was not without controversy, as the launch of Skylab 1 in 1973 was marred by the loss of one of the space station's solar panels during launch. This led to concerns about a number of measures to address these concerns and ensure the safety of future Skylab missions. Overall, the Skylab program represented a significant milestone in the history of human spaceflight and a major step towards the development of long-duration missions in space. The achievements of the Skylab 3 crew, including Alan L. Bean, Owen K. Garriott, and Jack R. Lousma, continue to inspire scientists, engineers, and explorers around the world to push the boundaries of what is possible in space. Another notable accomplishment of the Skylab 3 mission was the use of a special exercise program to combat the effects of prolonged weightlessness on the astronauts' bodies. The Skylab crew used a stationary bicycle and other equipment to exercise for several hours a day, which helped to prevent muscle atrophy and maintain their cardiovascular health. This exercise program was a significant advance in the understanding of how to keep astronauts healthy during long-duration spaceflights, and it has been used in many subsequent missions. The Skylab program also made significant contributions to our understanding of the Sun and the solar system. The Solar Observatory module of the space station contained a variety of instruments for observing the Sun, including a coronagraph, a spectrograph, and an X-ray telescope. These instruments allowed the Skylab 3 crew to make detailed observations of solar flares, coronal mass ejections, and other phenomena that are difficult to observe from Earth. The program led to many new discoveries about the Sun's behavior and its effects on the Earth's environment. The Skylab program was also notable for its international cooperation, as it involved collaboration with other space agencies such as the European Space Agency and the Soviet Union. The Soviet Union even launched a robotic spacecraft, called Cosmos 782, to study the Skylab space station and its environment. In conclusion, the Skylab 3 mission and the Skylab program as a whole represented a major milestone in the history of human spaceflight. The achievements of the Skylab 3 crew, including Alan L. Bean, Owen K. Garriott, and Jack R. Lousma, demonstrated the potential of humans to live and work in space for extended periods of time, and laid the groundwork for future missions to explore the solar system and beyond. Another significant achievement of the Skylab 3 mission was the successful repair of a critical instrument, the Apollo Telescope Mount, ATM. The ATM was a suite of solar telescopes that had been designed to study the Sun's atmosphere and magnetic field, but it had malfunctioned shortly after being deployed. The Skylab 3 crew, led by Jack Lousma, performed a spacewalk to repair the ATM, replacing a film magazine and a sunshade that had been damaged. This repair enabled the telescope to continue its observations for the remainder of the Skylab program and yielded a wealth of new data. Also made important contributions to our understanding of the effects of spaceflight on the human body. In addition to the medical experiments performed by the Skylab 3 crew, the program also included experiments on the effects of spaceflight on vision, bone density, and muscle strength. These experiments helped to identify some of the long-term health risks associated with spaceflight and to develop countermeasures to mitigate those risks. The Skylab program also paved the way for the development of future space stations, including the Russian Mir space station and the International Space Station. Many of the lessons learned from the Skylab program, such as the importance of exercise and the need for reliable life support systems, have been incorporated into the design of these later stations. Finally, the Skylab program had an important cultural impact as well, inspiring a generation of young people to pursue careers in science and engineering. The images and videos of astronauts living and working in space captured the public's imagination and helped to fuel support for continued space exploration.